Okay, Assalamualaikum and good morning or good afternoon. Okay, today we will discuss about revision for final. So in final, there will be 4 questions. Okay, so each question is okay. So you have 4, 2, 3, 4. Okay, and each question is 12. 25 marks. 25, 25, and 25. And the total is 100, and it will be 50% of your overall mark. Okay, so for question 1, it is for chapter 1 and chapter 2. Okay, and for question 2 is chapter 3, and question 3 is chapter 4. Okay, and question 4 is chapter 5. So the focus is here. Okay, this one already cover much in test 1 and test 2. Okay, but in final you also have to answer this, and for finals the focus is here. Okay, I'm not sure yet whether the time is 2.5 hours or 3 hours, but usually 2.5 hours. Okay, and you have to divide your question 30 minutes each. 30 minutes each. 30 minutes each. Okay. Okay, why? Because okay, previous student usually they cannot answer question 1 and then they take a lot of time, almost 1.5 hours, try to answer this, and question 2, 3, 4 they cannot answer because they don't have enough time. So for me, I suggest you one question 30 minutes. If you cannot finish within 30 minutes, you move on to the next question. Okay, question 2 and then question 3 and then question 4. Okay, so make sure you divide the time equally. Okay, 30 minutes for each question. Okay, if you cannot finish it, I suggest you move on to the next question because you cannot waste your time try to answer the question that you cannot answer. Okay, and for the question, when I look at the question, mostly the hardest one is question 4. Okay, for this year, okay, for this semester, the hardest question is question 4. Question 1 and question 2, question 1, 2, 3 is a little bit easier. For last semester, question 1 is the hardest. Okay, but for this semester, question 4 is the hardest. Okay, try to focus on question 1, 2, 3 first, and then Q4 is the last one. Okay, now we move on to question 1. Okay, so of course in test 2 test 1 you already answer nodal analysis. For test 2, of course, usually the other question. So if you want to do mesh analysis, okay, when you encounter any current source in mesh analysis, okay, for example something like this, okay, plus minus, for example, okay, when you encounter current source, okay, when you do a loop, okay, automatically when you do a loop, so automatically when the loop current encounter the current source, automatically I1 will equals to Is. Okay, but for this case it goes down, it's the opposite side, don't forget I negative Is. And if the direction is follow the loop current, okay, I1 will equals to Is. Okay, that what happen when you encounter current source. Okay, how about voltage source? Of course, when you encounter voltage source, okay, if the I goes into the negative, make sure it is negative, Vs, negative Vs. Okay, and if it at the center, okay, for example, this is I2, okay, so if voltage source, just ignore it, ignore I2, just put negative Vs, okay, don't this. And if the current source is something like this, the voltage source is, okay, the other way around, okay, I1 for example, so yes, this Vs is just plus because it is receiving the plus sign, so I1 is just plus Vs, okay, that is for voltage. How about resistance? So for resistance, okay, you have R here and you have I1 for example, so for this case I1 R1, okay, or usually I just write R Ri1. What happens if it's in between loop current? Okay, something like this. Okay, R, this one is maybe I1, this one is maybe I2. Okay, so if this happen, the voltage here is R I1 minus I2. If you do a mesh at I1, okay, but if you do mesh at I2, R I2 minus I1. So be careful, if you apply KVL at 1, so this is for this, and apply at 2, this is for this. Okay, that is mesh analysis. So make sure you know the difference. Okay, so okay, if the current, voltage source, and resistor. Okay, for current source, okay, this one is called super mesh. Okay, basically super mesh is when the loop current, loop current encounter current source. So this one become the super mesh, and automatically, as I mentioned before, the loop current become the current source, okay, value. So that is for question 1, chapter 1. How about question 1, chapter 2? Okay, question 1, chapter 2. Okay, for chapter 2, same like test 2, almost the same. Okay, you have to know L, R, C. Okay, how to convert it to the time domain to phasor domain or frequency domain. Okay, so you need to know how to do this, and don't forget the relationship between W equals to 2 pi F. Okay, because when you want to convert this, you need to use W. Okay, so ZL is JWL and ZC equals to negative J over WC. So don't forget, R remain constant. Okay, just copy back. Okay, and don't forget the series and parallel connection. Okay, when you have you need to know the series parallel connection, and make sure you know what this means. Okay, for example, this. Okay, and then you have something like this. Okay, and this one something like this. Okay, this means there is no connection. Okay, the wire is jump. Okay, jump, there is no connection. So no connection between this and this. But if the wire is something like this, okay, this is connected. So be careful, there is no connection if there is a semi round. Okay, and then you need to know how to calculate PQ. Okay, PQR. Okay, don't forget how PQS. Okay, how to calculate this. Okay, P is VI cos theta V minus theta I. This one Q same but sign. Okay, this is C. Okay, S is apparent power. Okay, so make sure you know what is apparent power. S is just equal to VI. Okay, this one is only magnitude. Okay, this one also magnitude, this one also magnitude. Okay, there is also a complex power here. Okay, if the question asks complex power, you have to use this formula VI. But for complex power, you have to use magnitude, the complex number. So means that in the calculation you have to include the complex, the angle. Okay, so this one doesn't include the angle. No angle at VI. Okay, but this one you have to include. And if you cannot use VI, you can use V squared divided by Z semicolon. Okay, reciprocal. Forget this. Okay, or okay, I squared Z. Okay, there is no this. Okay, and this one and this one don't include. Okay, don't include the angle. Okay, when you encounter squared, don't include the angle. Okay, and of course for final you have to know power factor correction. Okay, so you need to understand how to calculate. So in test 1 you only focus on the theory. Now you have to focus on the calculation. So of course make sure you memorize this formula. Okay, this formula C equals to Q compensate divided by V squared. Okay, V is just a magnitude, no angle. Okay, and W. Okay, so make sure you memorize this formula because it is not given and you will use this. This formula is not available in the slide, so make sure you know this formula. Okay, I mentioned it in the class, and I think there is not available in the slide. Okay, and don't forget to draw the power triangle. Okay, so remember when you do power factor correction, P remain constant. Okay, original Q. Okay, this one is Q1. Okay, original Q, and then you want to find the latest Q. Okay, this is Q2. Okay, so the composite is this one. So Q1 minus Q2 equals to Q compensate will be used here. Okay, and don't forget if it is unity power factor. So unity power factor means that Q2 is 0. Okay, so no need to calculate Q2. So basically C equals to Q1 divided by V squared W. Is if the question wants you to find unity P power factor. Okay, so make sure you know how to draw the triangle, how to use this formula. Okay, and how to calculate PF. Okay, power factor. Okay, theta, this is the theta 1, this is theta 2. Okay, but PF is just equals to cos theta. Okay, so make sure you know how to calculate power factor correction. Now we move on to question 2. Okay, question 2 is just basically 3-phase system. Okay, which is chapter 3. Okay, for this case, okay, for question 2, chapter 3, you need to know the positive and negative sequence. Okay, remember what is the equation, what is the relationship between positive and negative sequence. Okay, all of this is in the slide. Okay, make sure you understand how to do this. Okay, and then check back the assignment 2. Assignment 1. Okay, you just submit it. Okay, and try to refer back to this, how to calculate the voltage, current, okay, and the power, okay, for star, 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 delta, delta, star, delta, and delta star connection. Okay, so make sure you know what is line voltage or line current or phase voltage or phase current. So basically you just refer back to assignment 1, try to understand it back, try to memorize how the step is. Okay, this one you have to know how to do. Okay, the question will be one of these. Okay, so basically you have to know how to do this. Okay, and then I think many of you still don't know that P is basically as apparent power multiplied by power factor. So it is easier if you want to know the P power, okay, if you have the S or P, okay, apparent power or power factor, you can get the answer directly. Okay, VI cos theta. Okay, PF is basically cos theta, VI is basically apparent power. So you can use this formula. Okay, if they want to you to know what is power factor and they give P and S, so you just P divided by S. Okay, understand how to use this formula. Okay, in test 2 many of you cannot use this formula. Okay, and then okay, in the lecture session I don't show you the, okay, usually I just show you this form, right? Okay, how to draw using triangle approach. Okay, for example this one. Okay, this one is A, B, C, and this one can be also draw. Okay, if you want to draw this in the triangle form, also can. Rectangular form is also can. So make sure you know how to convert. You need to know how to understand the triangular form. Okay, for example something like this. Rectangular form. This is the rectangular form. Okay. Okay, so this one, so basically it is the same thing except you use the different approach. Okay, this is A, B, C, this is C. So basically this one, so AB is here, VAB. Okay, this one is VAB plus minus VBC. So this one is plus VBC minus plus minus, and then this one is VCA. Okay, plus minus VCA. Make sure you know you know how to understand the rectangular form. Okay, rectangular drawing. Okay, this is triangular drawing. Okay, this is triangular drawing. This is rectangular drawing. So make sure you know how to draw this and try to understand how to draw this. Okay. Okay. Now we move on to question 3. Okay. For question 3 is chapter 4 magnet. Okay. So for this one, I suggest you refer back to tutorial 1. Okay. Okay. So basically tutorial 1 is the tutorial I give you is basically almost the same as final. Okay, final question. So if you can answer tutorial 1 is basically easy for you to answer final question. Okay, there will be 2 parts. Okay, for part A is theory and part B is calculation or magnetic circuit. Okay, and if you don't want to answer theory, so that one is very bad because, okay, as I mentioned before, it is 25. So this one will be 12 mark. This one is 13 mark. Okay, if not mistaken, it's 12, 13 or 13, 12. So basically, theory is half of the mark and magnetic circuit is half of the mark. So make sure you memorize every theory available in the slide. Okay, definition, equation, all this will be question in the theoretical part. Okay, not all, but part of it. So make sure you refer back to the slide. Okay, and then for magnetic circuit, of course, you have to calculate. Okay, do the magnetic calculation. Okay, so for your case, okay, for your syllabus only series. No need to feel hard. Okay, because there is no series parallel. It's not hard, only a series circuit. Okay, for your syllabus. And make sure you know that mu r, okay, mu r for A gap is equals to 1. Okay, for material is more than 1. Okay, if you have material, it is more than 1. But if it is A gap, mu r, or relative permeability, okay, it is 1. Okay, and of course the important one, okay, make sure you use a SI unit. Okay, so if it is given in cm, make sure change it to m. So this case just divide by 100. So if cm squared to m squared, meter squared, make sure you divide by 100 squared. Okay, so make sure you convert this to SI unit. Okay, I think that is the focus. Okay. Okay, the last part is, okay, question 4, which is transformer. Okay. Okay, for this year, this semester, okay, this is the killer question. Okay, last semester is question 1. This semester, for me, is the killer question is the transformer part. So I suggest for killer question, you answer it last, because usually for killer question, after you answer it, you will be down. Okay, and you don't want to answer any more question. So I suggest this will be last question. So this one is good because it's basically last question, question 4. So no need to worry. So just keep the transformer question at the last part. Okay. For For transformer, you need to know the ideal transformer and non-ideal or practical transformer. So make sure you know what is the difference. Okay, so ideal transformer only like this, right? Something like this. Okay, then another here, something like this. For non-ideal, make sure you know what is the difference. Okay, what they have. Okay, remember something like this. Okay, inductor. Okay, what is called. Okay, check back. What is this called? What is this called? Okay, then this one. Okay, this one is the load. Okay, make sure you know what is ideal and non-ideal transformer. And then you have to know how to draw each type of transformer. So you have ideal, okay, practical, and then simplified or approximate. Okay, transformer, and lastly you have simplified or approximate without excitation current. Make sure you know how to draw this one, this one, this one, and this one. Okay, of course the ideal, just a simple. Okay, and don't forget to label it. So plus minus minus E2 plus E1 minus, okay, or just use this one. This one is plus V1, V2 minus I2. This is I1. This is plus minus. So plus minus V1. Okay, make sure you know this and the relationship. What happens if you bring this all to the primary side, to the secondary side? Okay, if you bring to the primary side, okay, don't forget that you have, this is ZL. Okay, so you bring to the primary side, ZL bar is equals to A squared. Okay, A squared ZL. Okay, A is N1 divided by N2, or E1 divided by E2, or I2 divided by I1. Okay, make sure you know this. Okay, and for practical transformer, okay, for practical, make sure you know that this one plus V1 minus, okay, you have resistance, inductance, okay, you have the excitation circuit. So this is RC, and make sure you know what is RC. Okay, core resistance, XM, magnetization, inductance. Okay, make sure you know all of this. You have to label, you have to know. This is R1. Okay, this one is basically copper loss. This is the flux leakage. This one is X1, and then this one R2. Okay, this is copper loss at the secondary side. Okay, so plus V2 minus. Okay, make sure you know how to draw everything. So this is I1 and this is I2. Okay, X2. So because this is the draw one, okay. Oh, sorry. This one, don't forget, this is still not bring to the primary or secondary side. So you need to know how to draw this. you have winding here, the transformer, and then the transformer. Okay, still not bring. Okay, and don't forget what happen if you bring this to the primary side to the secondary side. Okay, so basically if you bring to the primary side, okay, draw everything back. Okay, and then this one, and okay, this one all the same, but this one is R2 bar, X2 bar, okay, plus V2 minus, okay, bar. Okay, if you bring to the primary, and then what happen, you bring to the secondary, and then you have to know what the simplified approximate circuit. So simplified approximate circuit is basically you bring the excitation circuit to here, easier for you to calculate. Okay, you have to know the reason why this is possible. Theoretically, it is not possible. Okay, if you want to do a circuit analysis, this movement is not possible, but for this case, it is possible. You have to know why. Okay, so for this case, okay, you have to draw how you know how to draw this. Okay, this one inductor. Okay, and then this one is resistor. This one inductor, and this. Okay, this is R equivalent. This one is X equivalent. Okay, so R equivalent is basically R1 plus R2. Okay, A squared. If you bring to the primary side. Okay. Okay, this one is all bring to the primary side. RC X N. Okay, plus V1 minus plus V2 minus V2 bar. Okay, and this one is X1 plus A squared X2. Okay, so this is bring to the primary. Okay, and don't forget the current, of course. This is I1, and this means I2 bar. Okay, or I2 bar is just basically I2 divided by A. If not mistaken, this one. Okay, check back. Okay, and then okay, you have to know how to bring it to the secondary part. Okay, you need to know how to bring to the secondary part. Okay, and this one. Okay, check back your notes. So RC divided by A squared, XL divided by A squared. Okay, so this one is V1 bar. Okay, so this one R equivalent, X equivalent. So plus V2 minus. Okay, so make sure you know what is this. So R1 divided by A squared plus R2. Okay, this one is X1 divided by A squared plus X2. Okay, make sure you know how to draw all of these circuit. Okay, and lastly, okay, is if you without excitation current. Basically, you just remove this. Okay, just remove the excitation current. So basically, you have to know. Okay, you have to know a lot. Okay, there are 1, 2, 3, 4. There are 4 circuits. Okay, and each of the circuit can be referred to primary or secondary side. Okay, so basically something like this. You have 1, 2, 3, 4 circuit, and then each of the circuit can be referred to primary or referred to secondary side. Okay, you need to know how to draw 8 circuit. Okay, and label everything properly. Okay, so make sure you memorize everything, memorize and understand it. Okay, okay, of course, and when you want to answer this question, make sure if the question asks you to find the secondary voltage, this means is V2. Okay, if your calculation is V2 bar, make sure you convert this to V2. So basically V2 is, okay, V2, okay, V2 bar is equals to A V2. Okay, make sure you know how to convert this. Okay, if the question asks you secondary voltage, secondary current, okay, make sure you know. Okay, make sure you be careful, I2 and not I2 bar. Okay, make sure you complete the question. If not, you lose mark here. And of course, you have to calculate the power. Okay, the input power. So input power is basically PI. Output power. Okay. Okay, output. So V2 I2. And make sure no bar. Okay. Okay. And then you know the input power, you know the output power. You need to know how to do a voltage regulation. Okay, this one is quite difficult. Okay, so make sure you know how to draw this, how to answer. I look back at, okay, this is I2, this is V2. Okay, this is I2 R equivalent, I2 X equivalent. So you get a V1. Okay, so make sure you know how to draw this. I think this one is bar, right? This one is bar, and bar. Okay, check back the YouTube video I give you how to do a voltage regulation. Okay, because this is quite difficult. So you need to know how to do this. Okay, for voltage regulation. And lastly, you need to know how to calculate efficiency. Okay, efficiency is basically P out divided by P in multiplied by 100%. Okay, efficiency. And don't forget P in equals to P out plus P core loss. Okay, P core loss, okay, usually given. You can calculate also, but for your syllabus, it's not in your syllabus. And P copper. So copper loss. So copper loss, where you get this is basically I1 R equivalent. Okay, remember the theory. Okay, or if you use the, okay, this one, make sure you use this. Okay, if you refer to primary, make sure I1 multiplied by this one. Okay, so be careful. If you refer to primary, use the refer to the primary. If you refer to the secondary, make sure you use the refer to the secondary. Okay, make sure you know how to use this. Okay, that's it. 4 questions. Okay, good luck. Okay, good luck with your final exam. Okay, make sure you try your best to do this. Okay, you can check your carry mark and try to target the corresponding mark. Okay, I hope you can get A. Okay, that's it. Thank you. Have a nice holiday first, and then you can answer the final question. Okay, thank you.